This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Welcome to Dr. Tarazi's math site. Geometry is an important domain. 10 to 11 questions out of 48 are on the test. Draw, construct, and describe geometrical figures, and describe the relationships between them. Standard 7.G.3. Please pause the video and read the description of this standard.
Hello and welcome. Here is what you need to know before we get to the examples.
Two-dimensional figures.
Triangles. This is called equilateral. That means all the sides are equal and all the angles are equal. Isosceles, only two sides are equal and these two angles are equal. Scalene, sides are different and angles are different.
Two-dimensional figures.
Quadrilaterals. Rectangle, that you have two sides equal and parallel, two sides equal and parallel, and 90 degrees. All these angles are 90 degrees. Square is a particular case of a rectangle, the same thing except that all the edges are equal. Parallelogram, these two are equal and parallel, and these two are equal and parallel. Trapezoid, only this and this are parallel.
Two-dimensional figures.
Regular polygon, that's something we need to remember. Regular polygon has equal angles and equal sides. Okay? So, equilateral triangle, square, pentagon has 5 sides and all are equal. Angles are equal. Okay? Hexagon, all the sides are equal, all the angles are equal. Heptagon, octagon.
Three-dimensional figures.
Right regular prisms. The bases are regular and the sides are perpendicular to the bases. Triangular prism, square prism, pentagonal prism, sometimes we call it pentagon prism, hexagonal prism, heptagonal prism, octagonal prism.
Three-dimensional figures.
Right regular pyramids. The base is regular and the line from the apex to the center of the base is perpendicular to the base. That's the apex right here. That's the apex right here. Square pyramid, pentagonal pyramid, that's the apex, okay? This line here is perpendicular to the base. Hexagonal pyramid, heptagonal pyramid, and octagonal pyramid.
Three-dimensional figures.
Those are irregular figures, but we see them sometimes. This one we see quite a bit here. That's the rectangular pyramid. The base is a rectangle. And from the apex to the center of the base is parallel to the base. This is
three-dimensional figures.
This is a rectangular prism. And this one here, a hexagonal prism, irregular, because look at the base. It's not a regular base.
Three-dimensional figures.
You know the cylinder looks like that and the cone looks like that.
Recommendation.
To make the most of these videos, I suggest pausing the video when you see this button, solving the problem, and then resuming the video to check your answer.
Note.
All the following questions are calculator neutral. No, the calculator can't be used. They just need some imaginations.
Example 1.
A right square pyramid is shown. Select all of the figures that could result from slicing the pyramid with a plane. So select all, meaning more than one possible answer, okay? And you have here options to select it the way you want. So I'm starting to do it with a parallel to the base. Anytime you cut any pyramid parallel to the base, this will look exactly the same as this, except it's smaller. So you get a square. Okay, because that's a square pyramid. So the base is square. Now, if I cut it through slanted like this, you will get a trapezoid. You can also do it this way. And you can also get a trapezoid. Now, if I cut it through the apex, I will get a triangle. Okay, you'll never get a circle for sure, and a hexagon, you can't get a hexagon out of that.
Example 2.
A plane slices a right rectangular prism with dimensions in centimeters as shown. What shape represent the cross section? The cross section here is drawn for you. It looks exactly as this here. And this one here is 3 by 3 because this is a 3 here, that's 3 here too. So this one is 3 by 3. So it's this one here. None of these other ones. This one would work if you are crossing it horizontally. You can get this 3 by 8, which will be the same as the base, okay?
Example 3.
A right square pyramid is shown. Square pyramid. That means the bottom is a square. A plane intersects the pyramid through the apex and is perpendicular to the base. What is the shape of the cross section? Only one answer here. You're crossing it through the apex, and you will get isosceles triangle. You will not get a right triangle for sure. You will not get a square. You will not get a parallelogram.
Example 4.
A right pentagonal pyramid is shown. Select all, again remember that, select all of the two-dimensional shapes that can result from slicing the right pentagonal pyramid with a plane parallel or perpendicular to the base. Two options you have, parallel or perpendicular. The parallel is easy one. You will always get something similar to the one in the bottom, the base, except it's smaller, so you get a pentagon. Now I'm going to do slicing it perpendicularly, okay? Perpendicular. So if I do perpendicular like this, I get a triangle. Now if I cut it like this, I get a trapezoid. You would not get a rectangle for sure, and you would not get a parallelogram for sure.
Example 5.
A two-dimensional cross-section is created by slicing a pyramid parallel to the base. Pyramid. Parallel to the base. What statement best describes the cross-section? This is an easy question. Don't miss a question like that. The same shape as the base, but a larger area. The same shape as the base, but a smaller area. A different shape. It's going to be always the same shape, smaller area. When you cut it this way, it's going to be the same shape, but it's a smaller area.
Example 6.
Select all the solids that could be sliced horizontally or vertically to create a triangular cross section. Obviously, this would work. We just did quite a bit. We did a few examples of that. This one would work also because if you cut it this way, like that, you get the same as this triangle. This one, it will not work. If you cut it this way, you get a circle. If you cut it this way, you get a rectangle. This one doesn't work either. This would work. You can cut it this way. I don't know why it's not writing now. This started not to write.
Example 7.
A right square pyramid is sliced through its apex and perpendicular to its base. Through the apex. When you do that, a pyramid, you get a triangle for sure. You get a triangle. It's an isosceles triangle. Isosceles triangle. You can get a square, you can get an isosceles trapezoid, you can get trapezoid here.
Example 8.
This is an interesting example. I actually like it. A hexagonal prism is shown. Select the shape that is formed by each cross section. The first cross section is CDH. CDH. Obviously, it is a rectangle. The second section is AIJ. AIJ, draw it again here. AIJ. So I'm cutting it this way. Parallel to the base, it will look exactly the same as the base, which is a hexagon. The third option is ABEJ. ABEJ. That is a rectangle.
Example 9.
A three-dimensional figure is shown. Select all of the shapes of the cross sections that could result from slicing the figure as described. It's the same language here. First, parallel to the base. Parallel to the base, again, you will get the same as the base is only smaller. So you get a square. Perpendicular to the base through the apex, you get a triangle. Perpendicular to the base, not through the apex, you get a trapezoid. I think by now you probably got it. It shouldn't be too difficult. I think you can manage in the test.
Thank you and see you soon.
Thank you for watching. More videos to come. Please subscribe.